For our second example, we have that in September of 2020, the U.S. Senate consisted of 53 Republicans, 45 Democrats, and 2 independents. But what we want to do is determine how many distinct 5-person committees can be formed if each committee must have 3 Democrats and 2 Republicans, where the Republicans will be the chair and the vice chair of the committee. So this example has a bit more to it than our last one did, but it's a nice one to tie together everything we've seen from these first 3 sections. So in the first case, as we kind of have 2 cases here, the case for the Democrats and the case for the Republicans, when we are picking the 3 Democrats, we will be using combinations. As when we talk about this, we have 45 total, are picking 3, and the order in which we pick the 3 doesn't matter because they're just 3 equal members of the committee. So, when we choose our 3 out of 45, I'm not going to put out all of the work here for doing this. It's very similar to our last case. You'd take out that 45 and then a 44, 43, 42. See there's 42 factorial on the top and bottom. Organize some simplification, and what you'd end up with is something like 45 times 44 times 43 divided by 3 factorial, or, if you prefer, 3 times 2 times 1. I'll leave it to you guys to check where that exact number came from, for a total of 14,190 options. Meanwhile, for the Republicans, we'll have to use permutations, because when we're selecting the chair and the vice chair, the order in which they're picked is relevant. So, we have n equals 53 total Republicans to pick from, and we're choosing 2 of them. So, we permute 2 out of that 53, and that will give us something in the flavor of 53 times 52 times 51 factorial over 51 factorial for a total of 53 times 52, or multiplying that out, 2,756 total ways to get the 2 members of the committee who are the chair and vice chair from the Republican Party within the Senate. Now from this, for the total, what we have to do is use the fundamental counting principle. So the FCP, I misspoke earlier, where if we want the total number of options, it's the options in the first case times the options in the second case. So our total number would end up being 45 choose 3 times 53 permute 2, which you can actually run in the calculator fairly quickly, fairly easily, depending on what kind of calculator you have. But doing it by hand, you get something of form 14,190 multiplied by 2756 for a total, a very large total, of 39,107,640 total committees that could be selected of this form using senators in the year 2020, in the month of September of the year 2020 to be extra specific. So hopefully a big takeaway you're getting from looking at this is just how absurdly large the number of options you get when you're dealing with anything factorial flavored. And that's actually incredibly important, as for anyone who's interested in data security or computer science will learn or may already know, the growth of factorials, in particular, the growth of factorials being much larger than the growth for what are called polynomials, is an essential property that modern data security is built around.